So this is Terraform at Adobe. A little introduction. I'm a systems engineer at Adobe. I work for the team audience manager. Been with Adobe for 18 months. AAM was an acquisition in 2011. We're using 100% AWS. And if you want to stalk me on Twitter, go for it. So let's talk a little bit about HashiCorp. I know I'm saying that wrong, but I'm sorry. They make Vagrant, if you're familiar, in Surf and Packer and Console and Terraform. So can I get a raise of hands? Who knows what Terraform is? I assume everybody, because you're here. Who's using Terraform in production? All right. So as a little overview, Terraform is infrastructure as code. It supports a lot of providers. It supports AWS, obviously we're using it for that, and Azure and DigitalOcean and Google Cloud, and there's a lot of other services that it provides. We're just going to be talking about AWS today because that's, I think, probably the best use case right now. It's the best supported. So maybe about a year ago, we decided that we were going to need to automate our infrastructure creation. And so the question came up of why Terraform? Basically, it was fun to write. CloudFormation was really the only other good competitor. We had tried maybe 4 or 5 different systems, and CloudFormation is awful. Sorry if you guys use it and like it. I really dislike it. Terraform also has modules, so if you're familiar with modules in any way, it's a really easy way to extend, reuse code. The other thing that we really liked about it was that it showed this this execution plan. So you can say, hey, Terraform, what are you about to do? And it will show you. Another thing that we really liked was that it stored the state in a committable file. So after we finish making our system changes, we commit that code to version control. So as a basic example, a little weird kind of demo here is we have the main file, and we're going to create an AWS instance. We're calling it app. There's the AMI. We have 5 of them. There's a T2 micro as the instance type. That's the minimum viable that you need to create an AWS instance. We run the Terraform plan. It says it's going to create 0 through 4, which is 5 total. We say Terraform apply. It's going to create it. Apply complete shows us what we added, what we changed, what we destroyed. Go into the console. It takes about a minute. It does it all in parallel. So we have 5 instances. They're all running. Everything's all great. We could provision them after that, or if you want to provision them with user data or something like that, you could do that easily. Another thing that we needed was basically ephemeral environments. And we needed a way to quickly destroy those environments as well. Terraform does that perfectly. You say Terraform destroy. It asks you, hey, you sure you want to destroy this? Say yes, and it destroys it. Really easy. Again, it takes about a minute, and 5 instances are gone. So it does more than just the EC2 instances. It also does S3, and it adds CloudFormation if you really want to pull teeth. It does VPC, SQS, blah, 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 blah. So you guys probably aren't here to hear about the basics of Terraform because you probably know what Terraform is already. So the way that we use it at Adobe, at least on my team, is we broke it into 3 organizational things. Modules are native to Terraform. Compositions is something that we made up, and clusters was something that we also made up. And I'll explain what all those are. So modules is self-contained reusable code. The behavior changes based on input. And it's just regular, normal, totally vanilla Terraform code. We decided in using modules that we wanted a way to collect our information in a lot better of a way to make it reusable for different environments and for different purposes. So we came up with what we call a composition. And those are predefined collections of modules. And we're passing parameters to these modules, and we're using Terraform with Jinja. If you're familiar with what Jinja is, it's basically a templating system. So we can have variables that we're passing in from another system, which I'll explain in a little bit as well. It just made it a lot more flexible. I've seen some really fancy tricks, and we did a lot of fancy tricks in order to get Terraform to do what we wanted in the ugliest way possible. And we basically decided that we needed to use something else besides just native Terraform code to get it to do what we wanted. So for a quick example is like we wanted to do VPC peering, but only in some cases. So there isn't really like an if statement in Terraform. Jinja gave us that if statement. Clusters is the highest level. It passes the parameters to the composition. It's the ultimate source of truth. We write it in YAML. It's really easy to define. It's really easy to use, and I'm going to show a demo of that in a minute. So for an example for a module, the VPC module will have like the NAT instance and the Bastion instances and security groups and basic subnets for the DMZ and blah, blah, blah. Say the first application module will have the instances and the SQS queues and maybe the buckets and the subnets. The database module might have RDS and security groups and subnets, and the admin module might have instances and config management and monitoring. So for the composition, if we have an edge composition, we're going to put the VPC with the admin, with the app1 and DB1 and admin, and we're going to group those together, and that will be our composition. So if we want to have an edge composition that's for production, that's fine. We can just basically copy and paste that composition or reuse it with the clusters, and we'll have it for a non-production environment like QA. Same goes for the data processing composition. We're taking these Terraform modules and grouping them together, and we're calling them compositions. So if you're familiar with Puppet, it's a little bit like Puppet design. Terraform modules is really similar to Puppet modules. Compositions are basically roles and profiles. And the clusters is the ENC, the external node classifier, and however you say that H word. So the thing that really put it all together for us was the ops wrapper. And this was simple to make. We wrote it in Python. I said we were going to use Jinja. So it was basically what it does is it reads this YAML file, and then it reads the composition file, which is a tf.jinja2, and then it writes a Terraform file, and then Terraform runs against that. So to make things a little bit more solid in your mind, we're going to have a little demo. Is that the... All right. So really quickly, I've got this cluster. And this is showing the plan, so you guys know what the plan looks like if you're not super familiar. And I didn't do Terraform plan. And I'm going to show you the cluster file in a second, so this isn't just like black magic. It takes a minute to apply, so I'm going to go through the apply here. So here is our cluster file. We're baking in the Bodo profile, so we can look up our Terraform AWS credentials that way. We're pointing to which composition we want to use, and then we're passing the variables. So here we're going to enable the VPC. We've got US West. There's the VPC CIDR. We have subnets. We want a NAT in this case. We want a Bastion in this case. Those are the CIDR, so this is my IP address. We don't want the admin stuff, so we're not going to put like the Puppet Master or Nagios or whatever monitoring system you have here. But we are going to enable the edge application. Specifically, we want app1. Here's the AMI. Here's the count. Oops. We're using a T2 micro. We don't want the DB1. And then here's just variables that are passed directly to Terraform as variable files. This is still applying here, which is awesome. So as a quick example of the Jinja, we can see basically if this is enabled, then we're going to use this part of the composition. And here is Terraform compositions edge AMI. And this is the file that has been generated that shows it passing the AMI and the app instance count and the type and the subnets. Pretty straightforward. So it's creating any instances. Is there any comments or questions while we're like waiting for this minute or two? No pressure. Go for it.
Sort of went really quickly past checking in the state file to get. I guess when I looked at this last time, there was like secrets in that file.
Definitely, there are secrets in that file. Like we have RDS, and we're using passwords in there, and the passwords are just straight up in the state file.
You're checking those in and pushing them.
Yeah, so we're keeping access to that repo really limited to basically just our team, people that we trust, essentially.
You mentioned Jinja. That's a salt stack thing?
No, it's
Is that something you wrote? Is that open source?
no. So the ops wrapper is not something that we have open sourced, at least externally. But like I said, it's pretty simple. Basically, what we're doing is we're just reading this YAML file and then putting them into a Jinja structure and then writing it to a Terraform file. It really is like just a couple of lines of code, but it made it really easy for us to manipulate Terraform in the way that we wanted to. And to repeat the first question, because I'm supposed to repeat the questions, it was, do you have secrets in your state file? And the answer is yes. So we added 28 resources here. I created a ton of stuff. It created a VPC and some subnets in the application. I'm going to jump over to the VPC view here. And, probably have to refresh. So this is just like proof, guys, like you don't believe me. So we have this new cluster here. I created the subnets, blah, blah, blah. That's pretty straightforward. So that's not that great or groundbreaking, I don't think. And we used this for a long time. We really liked the way that Terraform worked, and we realized that we wanted this ops script to do a lot more for us. So again, this is not open sourced, I apologize, but I can show you some of the things that we have used Terraform and integrated other things into it. So this ops script, we're going to point to the cluster. Oops. So one of the things that we were doing is we wanted to migrate away from Fabric and to Ansible. And we needed an inventory file for that. So we're using this ops script to basically use Terraform to generate an inventory file for us. And that made it really easy to find all of our hosts without having to know its DNS name or its IP address or anything. We just go and look in there. Terraform knows what it is. It's really easy to do. So as part of that, we also built in this SSH command to it. So if I want to SSH to the Bastion host, we just say SSH to the Bastion host, and I'm in. Again, we don't need to know any of the DNS names. We don't need to know IP addresses. This instance was just created, and we already have access to it through this ops wrapper. So if we want to get into the app1 host, that's all fine and dandy. Just go in there, app1 if we have more than one of them, index 2. And again, I don't really think that this is needing to be open sourced. The code is not that complicated. I want to say that we probably have 100 lines of code total for like all this stuff that ops wrapper did, and it saved like hours and hours and hours of time. The very last thing that is of any interest is I was talking about Ansible. So we're going to do like a little fake deploy script here. It goes and uses that inventory file that I generated earlier. I'm deploying the app code, which is actually just installing Nginx. Since I'm targeting specifically the app1 service, let's go back to this guy and say, Nginx is now installed and running, like whoop-de-doo. So,
Sorry, is there like a variable interpolation in Terraform? Or you basically completely do that forever?
sorry, this thing is a little loud. Say that again.
If there was like interpolation for variables in Terraform, could you just like completely do it forever?
If there was variable interpolation in Terraform, could we get rid of the ops wrapper?
Yeah.
We'd probably still keep it for the deployment and stuff. But yes, that would be wonderful if we could have something like that. And I know that there's like really fancy ways that people are doing really cool things with Terraform. Well, yeah. And so we fought against using Jinja for a long time, and it became such a hassle, and we were bending over backwards to do all this stuff, and we just said, you know what, Jinja is easy. I know it's not native to Terraform, and I'm sorry if there's anybody here that's a purist, but HCL, the HashiCorp language, doesn't allow the flexibility that we wanted, and so we just said we'll get around it, and we're using mostly native HCL.
Is this also how you're handling things like rolling refreshes, like for auto-scaling groups?
For what was the last word?
For auto-scaling groups?
We're not using auto-scaling groups at all. Unfortunately, I wish that we were. It's part of our investigatory something in the future, but we're not using them at all right now. We've got a lot of infrastructure that's basically just static, and we don't need auto-scaling groups. And the part where we do need auto-scaling groups, we need some engineering time to actually get around it. Okay. Did I answer your question fully, though?
Yeah.
Okay. So we'll go back. So the future, we want Jenkins to run Terraform and commit the state file for us, because right now we're just running it on our machine, which is okay. Basically, we want to change the YAML file, hit push, and then let Jenkins do it for us. We also want the web interface, a web interface in front of this project to generate the YAML files for us, so that we can have like a front engineer going in there and check the boxes that says, hey, I want the front end piece and I want the VPC piece, and I don't need Puppet or Nagios, so let's just use those pieces. And then I would also really like to use the op wrapper to generate JSON instead of parsing the Jinja, because it still feels a little dirty. But for now, it's working for us. So some of the things that we've learned, some of the best practices, if you will, from our perspective, using a springboard for Terraform the ops wrapper for us is completely invaluable. Terraform was honestly pretty hard to work with before, and now it is wonderful. So Terraform HCL plus Jinja, I kind of mentioned this already, is a lot easier to read and write than Terraform JSON. One of the reasons why I really hated CloudFormation was because JSON is literally impossible for a human to write. So, missing commas and closing brackets and all that BS. Something that is a big deal that I know, Charity, you talked about, having one cluster, we're saying one VPC, one environment, and one purpose is absolutely essential. If you're generating all of your environments together in one state file, you're going to have a super bad time. And it also helps for reproducible environments. So if we have production, we can just go into that YAML file and change, if we have development, we can just change the YAML file to say production, and we have the exact same infrastructure, but it's production now. Versioning the user data in a map variable inside Terraform actually became a huge deal because we changed our user data a number of times. Basically what happens with Terraform, if you change the user data, it will destroy all of your instances and then recreate them with the new user data, and you don't want that. So for new projects, we would say, all right, we're going to version it, and the next one is going to be 1, and the next one's going to be 2. And honestly, we're only up to 3, I think, right now. So we did a pretty good job of making our user data what we wanted in the beginning. Symlinking shared files from modules to modules. We have a shared variables file that we're symlinking into all of our modules because it deduplicated a ton of work. I don't know if people knew that you could symlink, and Terraform just reads it. It's great. Also, we separated our common infrastructure. Like we have some SQS buckets that are shared by many different clusters and projects, and SQS buckets and IAM users and so forth. We made that its own cluster, so its own YAML file. Some things that we don't necessarily recommend to do is don't get impatient with Terraform. Terraform is not 1.0 yet, and you will run into bugs. Like guaranteed, you're going to have problems. And I've been running it since like 0.37 or 0.35. It's been a long time. A lot has changed. Terraform it's not a beta, but it's not 1.0. Don't go in guns blazing and use it in production in day 1. You're going to have a super bad time. And also, the Terraform documentation is amazing. Read the documentation. So right now, we have 85% of our production infrastructure managed with Terraform, and it's been fantastic. Any other questions?
What kind of books do you use?
What kind of books? Bugs? Oh, so many. I mean, basically, like, I want to destroy absolutely everything, and you say, no, please don't do that. A lot of things around security groups have been really buggy for us lately. I mean, not lately, the entire time we've been running it. It wants to, like, destroy your whole security group rules and then recreate them. There was also one really specific one that we ran into. I don't remember what it was, but it can get a little sketchy. But like I said, we've got 85% of it in production. It's been running really smooth for probably 6 to 9 months after we kind of figured out the weirdness of Terraform. And it's better than anything that we were using before. Terraform is, I mean. Any other questions? Perfect.
I'm
Oh,
going to use the mic.
oh,
All
the
right.
microphone. Perfect. I
Yeah.
forgot about that.
Here it is. So sticking point for me using Terraform, I guess, is still that state file. So if you could talk about, I guess a concern for me is like multiple people running Terraform commands at the same time. Can you talk about like how your team does that?
I don't know how most people work, but when I get into a project, the first thing I do is I git pull. And like, I don't know if that's just like not a thing, but people are learning really quickly that in this project, if you don't git pull first, you're going to have these super ugly merge conflicts, and I'm not going to help you with that. So go and do it yourself. That means git pull, do your feature, and then do it after that. And we have had some like pretty not messy merge conflicts where like this guy's adding instances and then this guy was adding security group rules, and that's fine because those are pretty separate and they merge nicely. But committing the state files has been basically a workflow issue of you need to pull before you try and commit or rebase or whatever you're doing. And you raised your hand?
So maybe a bit off topic, but like if your clusters in different VPCs talk to each other, like do you set up VPN bundles?
So that's where,
There's like no subnet conflicts and stuff like this.
We have a wiki page that has all of our infrastructure around the world, and we basically say, here are the subnets that I'm going to use around the world. Sorry, I don't know if the mic picked it up. The question was, if you have multiple VPCs, how do you get them to talk to each other, basically? And so we use VPC peering if they're in the same region, and otherwise we're just communicating over like S3, or having this guy in US West communicate with SQS in US East or something like that. Further questions?
Have you tried to use Word console and Terraform?
What was the console, like the other HashiCorp product?
Yes. All
No.
three are HashiCorp.
No, basically we're just using Terraform right now. And we are investigating console, but it's basically not even a POC yet. All right. Thanks, guys and girls.